This is also an important sum. Here it is given that A, B and C are vertices of a right angle triangle and angle B is 90 degree. First we draw the figure A, B and C with coordinates this and this. Now it is given here that angle B is 90 degree and the coordinate of C is, the y coordinate of C is not given. We have to find the value of this thing, the y coordinate of C, that is small t. Now by applying the Pythagoras theorem we get AC square equal to AB square plus BC square. Now simply by applying the distance formula we get this thing. Now after removing all the brackets we get the value of t as 1. Now the next example, show the points. 4 points are given and we have to show that these are vertices of a rectangle. First we will draw a figure A, B, C and D with their coordinates. Now by applying the distance formula we see that AB equal to CD, that is AB equal to CD means this side is equal to this side, and we also see that this side is equal to this side, that is BC equal to AD. Okay, so we find that the opposite sides are equal in length, so we can say that the figure is a parallelogram. Now we have to find that whether it is a rectangle or not. Now we find the length of the two diagonals, that is we have to find BD and we have to find AC. Now we find BD, we simply apply here the distance formula, and AC is the other diagonal, and we see that BD and AC are equal in length. So the figure is a parallelogram with the length of the two diagonals are equal. Hence we can say it is a rectangle. Now the next sum, it is given that PQRS are 4 points in a plane. Show that it is a rhombus and it is not a square, and we have also to find that the area of the rhombus. Now first what we have to do is we have to draw a figure PQRS with their coordinates. Now simply by applying the distance formula we find PQ, QR, RS and SP, and we see that the distance is square root of 26. Thus we see that it is a quadrilateral whose sides are equal. Now so there is a chance that it might be a square or a rhombus. We have to find it. So now we apply the distance formula and we find the length of the diagonals, that is PR and QS. But we see that the diagonals are not equal. So we can say that it is not a square, hence it's a rhombus. Now, what is the area of the rhombus? Half into product of the diagonals. If we put the value of the diagonals that we have got, we get the area of the rhombus as 24 square units.